Hello students, how are you all? Welcome to the second part of the chapter sound. Yes, it's an important chapter for class 9 as well as class 10th. And this is the second part, and in this part mainly we'll discuss about different numericals from the chapter sound. First part, if you missed the first part, the link of the first part is there in the description box. And in the first part we discussed about simple harmonic motion, means the wave of a sound. Okay, sound wave we discussed about frequency, amplitude, wavelength, velocity, all this, and the equation also we discussed. Okay, so the basic idea about a sound wave you will get in that video, and this video is a little bit in advanced level where we'll discuss different numericals. Okay, but before starting those numericals, I will tell you the required formula which are to be used for the numericals, which we are going to discuss now. So let us I'll tell you the formula first. Wait. So the formula is, first of all, the formula which you are going to use is V equal to nu lambda. Okay, V equal to nu lambda. Now what is V? V is velocity of sound. Velocity of sound, whose unit is meter per second. Okay. Now what is nu? Nu is frequency. Frequency, whose unit is hertz. Okay. Lambda. Lambda is wavelength. Wavelength, whose unit is meter. So as I told you in the first part, we discussed about this velocity, frequency and lambda. So if you have got any doubt regarding what is called frequency, what is called wavelength, you can watch that video. That video will clear all your concept. Okay, so this is the equation. One more equation we are going to use, like speed of the light equal to distance into time. This is a common formula. We know that speed equal to distance into time. This formula also will be used here. Now next formula is nu equal to 1 by t. Yes, frequency equal to 1 by time period. Okay, now based on this formula, okay, oh yeah, one more thing, nu you know frequency and t is time period, that is second. Now what is time period? I am not going to discuss it here because already we covered this part in part 1. Okay, so time period unit is second, and all these are the formula which we are going to discuss now. Okay, and one more information I want to tell you, that frequency, you know frequency. Frequency is the number of oscillations made per second. Yes, already we discussed in the first part of this video. Okay, so frequency is the number of oscillations made per second. Now, if the number of oscillations made per second, that is frequency, if the frequency is between 20 and 20,000, got it? Between 20 and 20,000, then we are able to hear that sound. We human, okay, human able to hear the sound if the frequency is 20 to 20,000. Now if it is below 20 or it is above 20,000, then we are not able to hear. Yeah, different animals are there who are able to hear those sounds, means those frequency is below 20 or above 20,000. They are able to see, they are able to hear, but we human beings are not able to hear those sounds. Okay, so what I told you, I told 20 hertz to 20,000 hertz. This sound we are able to hear. So this is called, this range is called audible range. Audible range. And remember, audible range for human being, for us, human being. Okay, and the sound below 20 hertz, okay, the sound which is below 20 hertz are called infrasonic. Infrasonic sound. Okay, the sound above 20,000 hertz, the sound whose frequency is above 20,000 hertz, we call it ultrasonic sound. Ultrasonic sound. Got it? So what is the audible range for human being? Yes, 20 hertz to 20,000 hertz, which we can hear. Okay, that is the audible range for us. As I told you, for different animals it's different. Okay, and the sound whose frequency is below 20, infrasonic, correct, and sound whose frequency is above 20,000, that is called ultrasonic. Okay, so we are ready with the formula, and also I told you some piece of information. Now all this information we require to solve the numericals from the chapter sound. Okay, for class 9th and 10th specially. Okay, so let's start. First, the numerical. See the first numerical. A bat can hear sound of frequency. Listen the question very carefully. A bat can hear sound of frequencies up to 120 kilohertz. Okay, bat who is able to hear the sound up to 120 kilohertz. So what is the frequency? 120 kilohertz. But this is 120 kilohertz, so I have to convert it. 120 then 000 hertz. Okay, kilohertz I am converting into hertz. Now just see this. We can hear up to 20,000 hertz, but see a bat is able to hear the sound up to 120,000 hertz. Can you believe it? The sound which our maximum range is 20,000, but a bat can hear the sound up to 120,000 hertz. Okay, so this is the bat who is able to hear the sound up to 120 kilohertz. Find the maximum wavelength of the sound. We have to find the wavelength. Okay, the speed of sound is, of the sound is 344. Okay, 344 meter per second. Okay, 344 meter per second. Now let us solve this sum. So we know that we'll use this formula, V equal to nu lambda. What is V? 344. What is nu? 120,000. Yeah, into lambda. Lambda we do not know, we have to find. So lambda equal to 344 by 120,000. Okay, now this 344 by 12 to 10 to the power 1234. I can write this. Okay, now by 12 you divide it. Like if I divide by 4 3s are by 4 fine. 86 by 2 28.6, and this 10 to the power 4 will go up into 10 to the power minus 4. This meter equal to wavelength. Fine. So wavelength of that sound equal to 28.6 into 10 to the power minus 4 meter. Hope you understood this. Let us go for another numerical. Okay. Next numerical. Ocean waves of time period 10 second. Okay. Wave. A wave is there. Ocean waves. Say this is the wave. We know that we discussed in the first part of this video. I told you this is the wave. Okay. Now we know that this is called crest. No, and this is called trot. Okay. Crest and trot. Now what is the question? 10 second is the time period. Yes, time period equal to 10 second, and velocity is 15 meter per second. 15 meter per second. Now find the wavelength of this wave. We have to find the wavelength, okay, and also we have to find the horizontal distance between a wave crest and its adjoining wave trough. Okay, wave crest and adjoining wave trough. So this is wave crest and this is wave trough. So where is the wave crest? Okay, this is the wave crest and where is the trough? This is the trough. So trough and crest. Now what is this distance? We have to find that. Okay, so the distance between crest and trough, we have to find this distance. Now if you have watched the first part of this video, whose link is there in the description box, you might have seen that the distance between two consecutive crest, this distance is called wavelength. Okay, and the distance between two consecutive trough is called wavelength. Okay, the distance between two consecutive crest and the distance between two consecutive trough is called wavelength. So this is also wavelength, this is also wavelength. But when you want to find the distance between crest and the trough, like crest and the trough, then this distance means lambda by 2. I mean half of the wavelength. Correct? Half of the wavelength is the distance between C and T. The distance between CC is lambda. The distance between TT is lambda. But the distance between C and T is lambda by 2. So what we have to do here? First we have to find lambda, then we have to find lambda by 2. Okay, where is this sum? Just you have to understand the language. So we know that V equal to nu lambda. What is V? V is 15 and nu we do not know, lambda also we do not know. Okay, but we know an equation that nu equal to 1 by t. Yes, let us use that equation. Nu equal to 1 by t. 1 by t. Now just put the value 1 by 10 into lambda. So lambda equal to 10 into 15, 150 meter. Then 150 meter. Okay, so wavelength equal to 150 meter. Now we have to find the distance between C and T. C and T. The distance between them is lambda by 2. So what is the distance between C and T? Is lambda by 2. That is 150 by 2. That is 75 meter. Hope you understood this sum. Let's go for another numerical. Next numerical is a wave pulse of frequency 200 Hz. Means frequency is given 200 Hz. Frequency 200 Hz. And moves a distance 8 meter. The distance covered by is 8 meter. Okay. 8 meter in 0.05 second. The time is 0.05 second. Means a sound wave is there whose frequency is 200 Hz. It's covering a distance of 8 meter and the time taken by is 0.05 second. So this is the distance, this is the time. We can find the speed. So we know that distance equal to speed into time. What is the distance? 8. Speed is 0.05. What is the time? We do not know. So time equal to 8 by 0.05. Got it? So if you cancel this point, we'll get 00 here. So now 800 by 5 is, you understood this? 800 by 5 means 160 second. Okay. Sorry. This is speed. This is time. Time is 0.05 second. So let us write it in this way. I made a small mistake. This is time into speed. Yeah, now it is correct. Just see speed. So speed equal to 160 meter per second. Correct? I made a mistake here. So that's why. Now it's correct. Understood? So distance equal to time into speed. Distance is 8, time is 0.0. This is speed equal to 160 meter per second. Got it? Now, what do you have to find? The velocity of the pulse. This is the velocity. Okay, velocity we have to find. This is the velocity. Next, what do you have to find? The wavelength. We have to find the wavelength. We know that V equal to nu lambda. Now, what is V? V is 160 velocity. Nu we do not know. Nu is 200 hertz. It's given in the question. Now lambda. So lambda equal to 160 by 200. 0 cancel. 2 8s 2 10s. That is 0.8 meter is lambda. Understood? So wavelength equal to 0.8 meter wavelength. Understood this sum? So let's move to the next sum. Next question. The speed of sound in air is 330 meter per second. Okay. So speed of the sound, or say speed of the sound in air equal to 330 meter per second. This is given in the question. And speed of sound in water. Speed of sound in water equal to 1650 meter per second. Okay, 1650 meter per second. This is given, and it given that it takes 2 seconds for sound to reach a certain distance when the source placed in air. You understood the question? The question is, when the source of sound is in air, then it takes 2 seconds to come to you. Okay, so time when the sound is in, source of the sound is in air, then time required is 2 seconds. Got it? Now they want us to find the time taken by the same sound when the source of sound is in water. Means when it is in water, what is the time required? Okay, so two different cases are there. In the first case, they mentioned speed of sound in air, and time required for that sound is 2 seconds. In the next case, they said that speed of sound in water, and they want us to calculate what is the time taken by that sound to reach us. Got it? And this is in water and this is in air. So let us find it. First of all, we'll calculate the distance. What is the distance in this case? We know that for this case, okay? For the first case means air. Let us write in air. Air equal to distance equal to speed into time. What is the distance? 330 into 2. That is 066 meter. Yes. Now in water. Water equal to distance equal to speed into time. What is the distance? 660. 660 equal to speed. Speed is 1650. Let me check it once. Yes, 1650 into time. So time equal to 660 by 1650. 0 cancelled. Now if you calculate it, 0.4 second. This is the time. 0.4 second time is required when the source of sound is in, yes, water. Hope you understood this sum. Easy sum it was. Now the last sum we'll discuss. Next sum. In the next sum, it is given that a sound wave of wavelength 2 centimeter. Okay, a sound wave of wavelength 2 centimeter. Fine. Is traveling with a speed of 330 meter per second. Fine. So whose speed is Speed of the sound is 330 meter per second, whose wavelength is 2 centimeter and speed is this. Now they are asking that, is this sound audible to us? Is this sound audible to us? Audible means the frequency has to be from 20 to 20,000 Hertz. Okay. If this sound frequency is from 20 to 20,000 Hertz, then we can say that yes, this sound is audible to us, otherwise not. So we have to calculate frequency. So let's calculate frequency. What is that? We know that this equation V equal to nu lambda. What is V? The velocity of the sound. I mean the speed of the sound. Speed of the sound is 330. What is frequency? We do not know. Lambda is 2 centimeter. 2 centimeter. And this is 330 meter per second. So nu equal to 330 meter per second, and this is 2 centimeter. But the problem is that this is in meter, this is in centimeter. Okay, meter, centimeter. So let us convert it. Now 330 into 100. Now this is centimeter per second by 2 centimeter. Yes, now you can calculate. Equal to this. So by 2 I am calculating this. 165. So 16500. This, yeah, Hertz equal to frequency. So 16,500 Hertz we are getting. The sound wave which is mentioned in the question, the frequency of that sound wave is 16,500 Hertz. And what we know, from 20 to 20,000 Hertz we are able to hear. Now this is 16,500, means we are able to hear this sound. Okay, so answer is yes, we are able to hear this sound. Understood? So I hope you got a clear idea about the numericals based on the chapter sound. Okay, and the numericals which we have mentioned here are very, very important for your class 9th and class 10th board exam. So you must practice that. Okay, see you in the next video. Thank you.